introduction. Hello, good morning everyone. My name is Usman-A and I'm senior researcher at University College Dublin. Today I'm going to present one of our research work that is graph-based framework to support data-driven urban building energy modeling to help the stakeholder to analyze the urban building energy data to make informed decisions and long-term renovation strategies. Today my presentation agenda, first I will start with the motivation behind this research and the research gap and the proposed methodology. After that we are presenting the Irish case study and finally conclude my presentation. When in urban scale, there is a lot of challenges for urban planner, energy policy maker and local authority, especially for building environment. Buildings are responsible for more than 40% of energy consumption. And one of the main reasons is more than 35% of buildings are very old and old structures. And also the 75% buildings are inefficient. Therefore, policymakers, they are looking for strategy and sustainable energy planning to improve the building energy performance. So there are a lot of strategies like building retrofitting, renovation resources, and decarbonized building. But there's different targets like EPPD, European standard, and also in Irish they have different targets to reduce the embodied emissions in building sector. They have target by 2030 and 2050. So during implementation these strategies, there are a lack of comprehensive model for stakeholder to effectively integrate diverse urban data. And because of there is a lot of data sets and interconnection is a very challenges to use this data for urban policymakers. Because of the dynamic nature of the urban planning and urban systems. There is a lot of other challenges when you use these urban data sets, like availability of data quality is also, and because of the different sector and different organization involved in this other main issues are of the data and also urban energy modeling to integrate all these data set for policymakers to analyze and make decisions. So therefore, this research will present a data-driven framework to help the stakeholders. The proposed methodology starts with the data collection from different resources, like building stock data in terms of building EPC energy performance certificates data. We can use the building geographical data and also the census, and similarly GIS and weather data from different sources. And after that, these are different processes. First, we start with data pre-processing because the raw data is raw format, and after that, in urban scale for urban energy modeling, is a lack of individual building data. So there's archetype approach is mostly used for that concept. So we could develop the archetypes at urban level. We perform some parametric simulation because of the currently you can say the EPC is not representing whole of the building stock. Suppose it represent only mostly country 50% and rest is 50%. The rest of them is bigger challenges. And to check the different scenario for future scenarios, this data is not available. So one of the best solution is you're doing the parametric modeling, and we can also do the machine learning to predict the rest of data by using all the available data. So these all data, machine learning predicted data, all the existing available data, integrate with by using graph-based database approach. And then the stakeholder have an interface to interact with this graph-based database for query and for analysis purpose. To represent the graph base, this commonly used ontologies concept. So here is the concept of ontology for urban energy modeling. So it used all the existing ontology. Because ontology people have already developed. So let's suppose in this case we have a building information ontology that presents all the individual building information like buildings, construction, equipment, and openings of the building. Furthermore, we have weather ontology that use the weather information. And similarly, building topology ontology that we give to the architect. Similarly, in University College Dublin, they have developed the dynamic district scale model that help to more extend to the urban scale level that represent all the geographical information, counties, neighborhood, buildings, certificates, and addresses. So we use all this ontology and develop our own ontology that is based on urban energy modeling and machine learning all the results that use archetypes, building parameters, construction templates, and also usage and predicted results. Here is the extended version of the conceptual ontology we have proposed. Connected all the different ontology and their information and entities to connect with to develop the urban scale modeling. So after developing the ontology, we have tested our results with Irish case study. Ireland, we have tested on residential building data. In Ireland, we have 2.1 billion residential buildings based on geospatial is record all these data sets. And EPC, the energy performance certificates, only available for 54% of the building stocks in Dublin City. So this case, Dublin, and that only presents. The rest of them is a challenge for stakeholder. Machine learning algorithms to predict the rest of them 46% of the building stock by using machine learning. And we also use all the existing one as well. And that all the pre-processed data and all the results mapped to the ontology by using Neo4j graph database. There is other options available, but in this case study, we use a Neo4j for our implementation of graph knowledge base. Neo4j is efficient, manage, and store complex data using proposed ontology for a Dublin City. Here is all the ontology and their resources because we have to use all the existing one and we have all developed. It's used all the Irish BER, the Building Energy Rating, and EPC Performance Database. We use the construction templates from different resources and also geodirectory and Irish census database that provide all the geographical information. For machine learning, we apply different techniques. In this paper, we not focus on machine learning. That is already published paper in journal. We use different techniques to develop the machine learning model at that scale. We use non-segregation. In this paper, you can see that we use different methods to predict and improve the machine learning performance. Segregation and non-segregation methods, we can do that because we are predicting energy use and efficiency per year per meter square energy usage. So instead of overall calculating the energy, we have divided all the heating, cooling, all the usage. So by using segregation method, we individually develop the model for heating, cooling, and water usage, and also all of them. That is the predicting only EY, we're getting the 76% accuracy based on energy rating. And if we use a segregation method, we have separately developed the model and then aggregate all the results. We have significant improvement and 99%. And we further extend by using ensemble-based modeling. We use different machine learning algorithms, gradient boost algorithm, and light gradient boost, and also histogram gradient boost algorithm. So we combine all these algorithms. These all the results available on this one. So we achieve 90% how to implement machine learning and help to improve the building model to them. When we have all the results from different resources, predicted result and actual result, all the other resources that we said, the main challenge is to represent the graph basically. You can see that there is a connection between all these data, so counties, buildings and predicted a small area. You can see the very complex graph connected all the results each other, and you get, because it's urban area is very complex dynamic, already discussed in the start. So you can see in these results how there is connection. When we have we develop the graph-based database, and we can use this for different analysis. Like here we have example of maps. We can present our data to see the building energy rating. So EFG is all the poor performance building rating. Mostly we use similar like a grading system. A is a good rated building, and G is a poor performance building. So EFG is all the poor performance building, and C is average building. We can see in the graphs in individual buildings that this data is not available before for stakeholders. So this is complete data available for analysis. Similarly, they can see the actual distribution of whole Dublin City instead of 50% stock. That gives you more. You can see that there is a lot of G building, FG building in these stocks. So finally, I would like to conclude my presentation. In this study, we have developed a novel data-driven framework that use different process data collection, preprocessing, archetypes, and also parametric simulation and machine learning modeling result integrate the data from different sources. And we have created the graph-based ontology for query engine and also for comprehensive analysis. This helps to stakeholder to analyze the predicted result and different scenarios they can analyze. For future work, we have continuous improvement of this ontology and maybe extend and add more information. And future work will be over more advanced machine learning algorithms and also for best prediction scenario. We also we connected this ontology with the grid and all the different future scenarios like PV and more renewable resources and studies we can add in general paper. And that's all for today. Thanks for your time and attention. If you have any question, I'm happy to answer.